Good afternoon friends and welcome to the workshop. In this video we're going to finish off the Bogie hopefully by machining the wheels and the axles. The first piece of work to do on these wheels is to just clean them up with files, and I think you've probably seen pieces of metal being filed, so I'm just going to be getting rid of all these little webs here, trying to knock off maybe the sprues from the casting and these little marks here, and get these all filed up. Here's one of the drawings for the H2. This is the Bogie axle we need to build, and here is the Bogie wheel. So by my estimation, that is going to be 5/8 in total width, with either 1/8 or 1.5 or 1 5/8 in diameter. So I'm going to figure out how to do that, because that's obviously an 1/8 difference, and the driving wheels are defined as the standard size anyway. So yeah, let's figure that one out. Right, we have the wheel chucked up by the tread. This is the Bogie wheel casting, chucked up by the tread to face the back of. I've got the other wheels here, and I'm going to be batch turning these. The first ask is to face the rear of the wheel, and then flip it around and centralize the boss on the inside, more or less. So I'm going to leave that and chuck up the others and get them face down in the same way on the rear, and then come back to you. Better to measure this before we start taking cuts, I think. It does seem that these wheels came as two pairs, one that was about 450 thou thick, and one that was about 500 thou thick. So I'm guessing they were two halves of the same mould, or maybe the mould got moved. I tried a lower speed on that, and it seemed to make little difference, so I'm pretty sure it's my tool geometry that needs to be fixed. Annoyingly, it does a pretty good finish on steel, clearly less ideal on. Here we have the 4 wheel castings with the backs all faced up. So this is a technique that I have used on the mill. There's a piece of polystyrene or foam between the two parallels to try and hold them against, or in the mill's case, against the fixed and the movable jaws, rather than flopping around. But in here, I'm going to give it a shot and see if I can get it to fit between these two, so I don't have to try and hold this with 3 pairs of hands. That's the theory, and then the wheel will sit on the jaws like that, and then I'll take out the parallels and the packing behind. But it will allow me to seat repeatably these without having to try and hold these parallels in place at the same time. Must highlight that I'm incredibly pleased that fit first time. This isn't like the 20th take, I actually did that first time, which must be a record for me. what I'm doing, I'm trying to eyeball the boss against the tip of the tool, because I could use an indicator, but it's already a rough surface, and I think I'm just going to end up taking a very long time to get a not very accurate result anyway. So this visually, I think, is pretty good. I do apologise for the pretty abysmal camera angles. I'm going to try and find a way to mount a camera against this wall for the lathe, so I can go in this way. As it stands though, we've got a fairly simple operation. This is 435 thou thick, and it needs to be 375. So we need to go in by 60 thou to get this front boss the correct thickness from the rear face that we've just faced off. Once that's done, I'll dial in another 63 thou to get the front of the wheel, front of the tyre, to the correct thickness as well. So here we go. Looks like I misread the dial. We need exactly 25 thou more to come off. Right, that is now 375. If it's not 375, I'll eat my hat. Yes. 375. So I'm going to note down the hand wheel dial here. So we're just at 50 here. So I now know if I then use another set of parallels, push the wheel in, get it locked in place, and then this ultimately comes around to end up at 30, all of the wheels will be the same thickness at the boss. Then we now know from 30 to come in at exactly a 1/16 of an inch for the face of the wheel. We need to go in 63 thou total. So we know that this 30 is going to end up being 93. So let's center drill. This is 15/64 because we're going to ream it to final size. Just turn the speed down for the reamer. I now need to resist the urge to touch the carriage lock or the or anything relating to this, because I want to remove this, chuck the next one up, and repeat those operations each time. So if I go in and try, oh yeah, I'm just going to go in and cut these shoulders, I will have messed up the dial on here, and there will be no way for me to get that back. What you're seeing inside the collet chuck on the lathe is the same piece of 1/2 inch steel that I have used as a mandrel for all of my cylindrical turning operations so far, it seems. You last may have seen it as the mandrel for the Stuart 10V flywheel. Now it's performing the same duty for the Bogie wheels. The first job in this setup, this operation, is to get the right thickness for the tyre, and then get that tyre down to the correct diameter. So the thickness should be 1/4 of an inch, and the diameter should be either 1 5/8 or 1 1/2 inches. And those are both specified on the documentation. It doesn't say which one to use, obviously, so I need to do some research and make sure I get the right diameter for these Bogie wheels. Much like the front face machining process, I'll be doing this as a batch. So I will be having one wheel on here, and then I'll be noting the positions of these wheels when I have got this to the correct size. When this is the correct size, I know that I can undo these wheels, remove the wheel from the mandrel, place the next wheel on, turn these dials back to the way they were before, and I know that the next wheel will come out exactly the same as the wheel you can see here. So let's get on with that. These are a good push fit on, but they are it does move, as you can see. So while I can take small cuts with it in this situation, I think I'm going to need something more substantial, especially when I start cutting the flange, which has a 20-degree taper, so will be a form tool of some kind, and will introduce lots of tool pressure, which I think is going to cause this to just slip around the mandrel. Unsurprisingly, the just that grip on the mandrel wasn't enough, so I've made a little top cap here. It's a 5BA clearance hole, and this is 17/64, so just over a 1/4 inch counterbore, and this will fit on the end of the mandrel. And then here's a 5BA bolt that I will put through here and into the tip of the mandrel, which has now been threaded. Just did this first one off camera just to test if my methods worked, and they were okay. And yeah, got it down to 1 5/8, pretty much bang on, which is nice. I didn't use the lead screw hand wheel or the top slide for this here. I actually just went up to this scribed line. So I think what I'm going to do is get them all roughed out to this, with still probably a 64th or maybe a 32nd up to that line. Get them all like this, then get it locked in, get them remounted, and I'll run through the final dressing of this flange here as a last operation. Just going to get those done in the same way, and I'll come back when I'm refining the flange radius and the flange angle and so on. I really wanted to finish the wheels and the axles in this video, but I'm actually going on holiday for a week on a narrowboat, and this video is already like 7,000 hours long, so I'm just going to show you the machining of the last wheel, the process I'm doing to get it to that rough size that we've spoken about. And then I'm going to have to call time on this video and finish it in the next one. Right, what we got here is the wheel set up in that clamped mandrel. I have the cutting tool advanced. We've got about 100 thou to bring it in by, to get it to our desired thickness. So I am just gonna get that done. You're going to have to forgive the wobbly camera, because you're sitting on top of a tripod, which is then on top of a footstool to try and get it to the correct height. What we're going to find as a problem is when we start cutting into the main part of the tyre. You see we're currently cutting the flange still. There's going to be a lot of forces involved, and I've already sheared off a couple of these 5BA bolts, which I'm using to hold the cap in due to the cutting forces. So I'm just going to take it very gently. So that's now the exterior diameter of the flange. We've now achieved here, which is 1 inch 803 thou. What we need to do now is to sort the tyre out. There we go. So there we go, that's the last Bogie wheel roughed out. I'm now going to figure out the exact movements of this top slide I need to make to get that flange down as low as possible. Okay, so that actually was quite easy. I just held the calipers up to the rim of the wheel and just kept turning the top slide dial. I ended up at 85. So I'm going to rechuck the rest of the wheels, and actually that will be the wheels done then. So it's just going to be the axles and the final assembly in the next video.